create an extra layer of a plasma membrane around the axon. And this is going to serve, like we stated, as insulation. It's going to have multiple kind of like support. It supports the axon. Remember, the axon is like a long tunnel or a long wire. This wire can kind of become flimsy, and that might affect member function and structure go hand in hand. So the myelin sheet, it will kind of support it, and it will also help insulate it. So instead of having these protein channels found throughout the plasma membrane, these protein channels are only going to be found in these certain spots. To be more specific, it's called a node of raniver, but it's alright. Just know the myelin sheet and know you don't have to know that so much detail. So what might be the benefit of only having these protein channels in certain spots where it's not covered? Think about it. Wouldn't more sodium ion channels be more beneficial?
Yeah.
Can anybody kind of guess?
Wait, can you state your question again?
Okay, so axons that are myelinated, they don't have voltage-gated channels all throughout the axon. They only have it in certain spots of the node of raniver or certain that are not myelinated. So you'll only find voltage-gated channels in these spots. However, the myelinated axons conduct nerve impulses extremely faster than unmyelinated axons. So even though they only have certain spots of voltage-gated channels, why might you guys think this is? Or what might be the cause of this? If I can rephrase that better. Think about it. Have you ever, okay, so I'll relate this to walking. What might you think be faster if I were to take tippy-toe steps, or if I was to jump to a location?
Jump.
So I'm going to relate this to walking. So think of the signal as this. As one gate opens, the other one closes. As one gate opens, the other one closes. But what happens if we have different gates, and this one opens, and it closes, and then I go to the next one? So that's basically what's happening to the myelinated axons. As one signal opens, it automatically jumps to the next one because this charge is going to shoot forward. So you can see it right here. It's doing a good job depicting. So this influx of sodium ions is going to rapidly jump to the next one, and this one is going to close, and so on and so forth. Does everybody understand that? I just want to make sure. One more time. Does everybody understand how myelinated? No? Okay, I'm going to do it one more time. So pretend I'm an unmyelinated axon. I have sodium channels all over my axon. So it's like this. As one opens, the other one closes. As one opens, the other one closes. As one opens, the other one closes. And you see how this kind of effect could be kind of slower? But a myelinated axon, it's like this. So one closes, and then I jump to the other spot. You see how I move faster? So does that kind of clear it up a little bit?
Yeah.
Okay. So that's basically how it works. It insulates, and it also shoots. It kind of shoots the signal. And you can see it right here. So voltage-gated channels, this is very important. Voltage-gated channels are only found in these certain spots where they're not myelinated. So you're going to have their code specifically, right here. So copy this down, please, everybody. Because I guarantee there's going to be something of this manner on the assessment.
Copy the picture too?
Yeah, if you want to. I mean, it's not much. You just draw like a simple structure, and that'll be fine. I really appreciate those of you that take pictures of my slides because I do put a lot of effort. However, it's not like you're not going to remember it, and you're probably not going to check your phone if you. I mean, those of you maybe you will, but however, I highly recommend you write it down because memory is more, you're more likely to remember something if you do write it down. How are we doing with the video? Good?
Video.
Yeah.
It's good.
Oh. Watch it on sound.
Okay. Next slide, everybody. So, question number 3. Which disease is an autoimmune disorder where white blood cells attack the myelin sheet of the axon? Oh, okay. You guys.
What?
Oh, good. All right. I just want to. I know you have your hand up. I just want to give everybody time to answer.
Obviously obesity. Obviously.
So, does anybody want to give it a? Somebody I haven't heard from.